Hello students, welcome to this theory session of atoms and molecules. In the previous session we have discussed about the laws of chemical combination. That is the law of conservation of mass, the law of constant proportions, right? Now what law of constant proportions states? That elements combine in a simple ratio to form a compound, or in a compound, the elements exist in a fixed ratio by mass. Now, what are these elements exactly? What these elements are composed of? Nobody knows. About what is the entity which is undergoing reaction, or what is the entity which is undergoing this combination. So in order to explain these laws, that is laws of chemical combination, and also the nature of matter, a British chemist, John Dalton, provided his theory or proposed his basic theory about the nature of matter. So we will be discussing about this Dalton's atomic theory in this session. So let's start our theory session, students. So Dalton, he picked up the idea of division of matter, right? Matter, if divided into the smaller units, the smallest unit which you will be getting, which is indivisible, that unit is a basic for that particular matter. Now Dalton proposed the term atoms. That particular, the smallest unit of matter is called as atoms. Atoms is derived from the Greek word, right? And this is the smallest particle of matter. He also suggested that this atom is indivisible. It cannot be divided further. And it is an atom which participates in a chemical reaction or which forms a compound. That is why the elements exist in a fixed combination or fixed ratio by mass in a particular compound or in a compound, irrespective of the source. So let's start Dalton's atomic theory here. Let's start discussing about Dalton's atomic theory. John Dalton, that is his duration, the 1766 to 1844, he proposed the basic theory about the nature of matter around 1803. Till 1803, there was no theory about the nature of matter, or the nature of matter was not clear to the people. Dalton's atomic theory provided an explanation for the law of conservation of mass and law of definite or constant proportions. He suggested that all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. So atoms are the basic units, as cell is the basic unit of life, or cell is the fundamental unit. So atoms is a basic unit. An element or a compound or a mixture, the smallest particle present over there is atom. Let's discuss about the postulates of Dalton's atomic theory. The postulates of Dalton's atomic theory are: all matter is made up of very tiny particles called atoms. See, this copper is there. This copper is made up of these tiny particles. In the image it is looking to be bigger, but actually it's very, very small. Right? So these small balls, they are the copper atoms. So these are copper atoms. Right? Now let's proceed. Atoms are indivisible particles which can neither be created nor destroyed in a chemical reaction. It states that this is atom. Now the copper atom, it is indivisible. That is, this atom cannot be further divided. And secondly, there is, what was the law of conservation of mass? That mass is conserved, or matter can neither be created nor be destroyed. So here he suggested that atom can neither be created nor be destroyed in a chemical reaction. His third postulate, atoms of a given element are identical in all respect of mass, shape, size and chemical properties. That is, all the elements or atoms of a given element, say if it's copper or whether it's iron or sodium, these are the symbols, chemical symbols. We'll be discussing about them later. Now these are composed of atoms, and these atoms are identical in all respect of mass, that is, they've got the same mass, shape, size and also the chemical properties. Say we have taken the example of copper. Let's get back to it. Here, whatever atoms are present, they all have similar mass, right? Shape, you can see they're all spherical. Size, you can see they all are identical. And the most important thing is the chemical property. Right? So this was one of the postulates of Dalton. Atoms of different elements have different masses and chemical properties. Of course, atoms of copper will not have the properties similar to the atoms of iron. Or atoms of iron will not have similar properties to the atoms of sodium. Do remember this. Atoms combine in the ratio of small whole numbers to form compounds. A chemical reaction is a rearrangement of atoms. See, if I'm taking H2 plus O2 forming twice of H2O. So nothing is created, nothing is destroyed. What is happening is simply the atoms are rearranging and forming a water molecule. That too, the atoms of hydrogen are combining in a fixed ratio by mass with the atoms of oxygen and forming water molecule. Right? So a chemical reaction is a rearrangement of atoms. And these atoms combine in small whole numbers to form compounds. The relative number and kinds of atoms are constant in a given compound. See, say in a given compound H2O, the number of atoms of oxygen is 2. Sorry, the number of atoms of hydrogen is 2. Oxygen is 1. HCl, the number of atoms of hydrogen is 1. Chlorine is 1. NH3, the number of atoms of nitrogen is 1 and hydrogen is 3. Then take another compound, nitrogen dioxide. In this compound, the number of atoms of nitrogen is 1 and oxygen is 2. Right? Likewise, N2O5, nitrogen pentoxide. The number of atoms of nitrogen is 2 and oxygen is 5. Likewise, they've got a fixed ratio by mass also. So these are the postulates of Dalton's atomic theory. It's very simple, students. All matter is composed of tiny particles called atom. The smallest particles called atom. Let's take up this copper again. Matter is made up of smallest particles called atom. Atom is indivisible. Right? It can neither be created nor be destroyed. Second postulate. Third one is what? The atoms of a particular element or a given element or any element is identical in mass, shape, size and chemical property. Atoms of different elements have got different mass and different chemical properties. Now it is the atoms which combine in fixed ratio or which combine in simple ratio. And last but not the least is the relative number and kinds of atoms are constant in a given compound. They do not vary. Right? So these are the postulates of Dalton's atomic theory. Now there is a very simple question here. Which postulate of Dalton's atomic theory is based on the law of conservation of mass? Which postulate? That atoms are indivisible particles. Indivisible particles. And secondly, atoms can neither be created nor destroyed. Right? So this law of this postulate is based on the law of conservation of mass. Fine? Previously there was conservation of, the law was given that the total mass remains conserved and all those things are there, that matter can neither be created nor be destroyed. But what that matter is composed of? There has to be something which is to be created or which is to be destroyed or which is taking part in the reaction. So these postulates are based on the law of conservation of mass, or these postulates, they explain the law of conservation of mass also. The next is, which postulate of Dalton's atomic theory can explain the law of definite proportions? Which postulate? Atoms combine in the ratio of small whole numbers to form compound. Right? Because half atom cannot participate. It's single atom. So there is ratio of small whole numbers. And secondly, the relative number and kinds of atoms remain constant in a given compound. There is a composition remains fixed. Right? I'm sorry. The composition, that is a ratio by mass of elements in a compound, remains fixed, or in compounds remains fixed, irrespective of the source. So these two postulates, or these postulates, are based on these laws. That is the law of constant proportions, or the law of definite proportions, and the law of conservation of mass. Now, what were the drawbacks of Dalton's atomic theory? The very first one was that the atom is further subdivided into electrons, protons, and neutrons. So later it was discovered or found that the atom is divided into electrons, protons, and neutrons. So his first postulate, or his second postulate, that atom is indivisible, is wrong. Right? That atoms is further divided into electrons, protons, and neutrons. Say for example, I have taken here oxygen atom. It is composed of 8 protons, 8 neutrons, and 8 electrons. Right? So atom is not indivisible. Atom can be divided into, or atom is divided into electrons, protons, and neutrons, and these are the smallest particles. His postulate that atoms of same elements have got same mass, same shape, size, and chemical properties. was also proved to be, later it was also proved to be wrong. Later it was found that atoms of same element can have slightly different masses, as in the case of isotopes. Now what are isotopes? They have same atomic number but different mass. Say atom of hydrogen. It is according to Dalton's atomic theory, atoms of hydrogen have got similar mass. But if I take up the isotopes of hydrogen are hydrogen, deuterium and tritium. The masses of their atoms are 1, 2 and 3. The mass of hydrogen atom is 1, the mass of deuterium atom is 2 and the mass of tritium atom is 3. That is, it is no more that the mass of atoms of same element is similar. Right? They have got slightly different masses. Say chlorine also has got two isotopes. One is Cl35.5 and Cl37.5. Right? Likewise, iron also has got its isotopes. Fine? Now, atoms of different elements have different masses. This fails in the case of isobars. What are isobars? Isobars are the elements having same atomic mass but different atomic numbers. So what it suggests, what Dalton's atomic theory suggests, that atoms of same element have got similar atomic masses, but isotopes do have different atomic masses. They are the isotopes of same element, that is hydrogen. Deuterium and tritium, they are the isotopes of hydrogen. Atoms of different elements have different masses. Now this fails in case of isobars. Isobars have got what? Different atomic numbers but similar atomic masses. Say argon. Argon has got, argon, I'm talking about single atom. An atom of argon, the mass is 40 and atomic number is 18. Atom of potassium has the mass 40 and atomic number 19. Whereas atom of calcium, it has got the atomic mass 40 but atomic number 20. So this postulate also fails in the case of isobars. So these are the drawbacks of Dalton's atomic theory. Though it was a very first theory to explain the nature of matter, but still it has got certain drawbacks. Right? So this is all about this session, students. In the next session, we'll be studying about the symbols of elements, the chemical symbols of elements, and then the atomic mass. What actually is atomic mass? I have told you that the mass of calcium is 40, the mass of carbon is 12, the mass of nitrogen is 14. But what exactly is the mass? What is contributing to mass? See, there are three entities in an atom: the electrons, the protons and the neutrons. Now what is contributing to the mass? We have to discuss about that. So we'll be studying about the atomic mass. See, atomic mass is due to the presence of protons and neutrons. Right? So we'll be discussing about atomic mass and also about the molecular mass. Right? I hope you have enjoyed this session, students, and do attend the next session. It is also one of the important one. Right? So thank you, students, for listening patiently, and do have a nice time ahead.